All right, chapter 8, start of a new chapter. This is on volume and surface area. So we start off with the first lesson on the volume of cylinders. So again, notice that they want you to do a volume of a cylinder. In previous years, you've not gotten to a volume of a cylinder until after you've done a few other things. So let's just review basically what volume is, and then we can go into how a cylinder makes it different. All right. So until now, you've probably, let me get to the right thing down here, probably done like volume of a cube or volume of a prism. Let's take that up that way. Sorry about that. So you would do like area of the base, area of the base. Area of the base times the height. And some of you even may have done like length times width times height. Well, that's fine if you're dealing with cubes and prisms. If you're not dealing with cubes and prisms, that won't always work. Because whenever you talk about like a cylinder, when you talk about a cylinder, does it have a length, a width, and a height? All right, so when you talk about a cylinder, sure, it has a height, but when you talk about length and width of what? A circle? We never talk about that. So this is kind of an outdated formula to find the volume of anything. And even whenever I teach the volume of prisms, such as that, I don't ever teach that. This is what I say will work for anything that we do. Now notice that is a capital B. That capital B stands for area of the base. So no matter what the base is, now remember the base would be, you have two of them, right? It's not always what it sits on, but generally it is. So two parallel bases, so top and bottom. It's area of the base times the height. So this would work for this one, right? If this is a cube, you take the area of the square at the bottom, which is length times width, and take it times the height. So that works. It's the same one that we've had, area of the base times the height. But it also now takes into consideration the fact that you may have a circle as a base and not just a square or a rectangle. All right? So we're going to get some practice on that. But before we do, I just want to look at this example that I have here on the page. I know at some point in time in the past, you've had to like guess the number of jelly beans in a jar, guess the number of whatever in the jar. That is a practical application of volume. So when they talk about actually the grid paper here, now you're not going to say, oh, let me guess how many it is. Wait a minute, let me get my grid paper, let me trace the bottom, let me see how many. No, but anytime I have to do it, I will hold the jar up, look to see how many form a layer at the bottom, and then kind of guesstimate, which means estimate with a guess, how many layers that thick are in the jar. Because really that's what volume is. It's you have one layer across the bottom, you have one layer here across the bottom, and then how many layers thick is that up the jar? So you find the area of one of these layers and then take it times how many layers you have. That is volume. That's what I mean by whenever I say area of the base times the height. Okay, so with all that being said, let's move on to find the area of some volume of some cylinders. Okay, so they have stolen my formula right here, capital B, H. They say stolen mine like I invented it, but whatever. Capital B. B means this. Now, what does that mean? What is that pi r squared business? Well, that is the formula for the area of a circle. Pi times radius squared. You will need to commit that to memory when we're talking about circles and volume. Because if we want to know the area of the base, and the base is a circle, you have to know how to find the area of that circle. Okay, so pi times radius squared. And again, if you're talking about a circle, radius is the part that's halfway across. What's the part all the way across called? Yeah, that's the diameter. So we don't want all the way across. So if they ever give it to you all the way across, you will have to make the necessary adjustment. So we want area of the base, which is this pi r squared business, area of the base times the height. Capital B means area of the base times the height. Commit that to memory, please and thank you. All right, so let's look at the first example here. Find the volume of the cylinder, round to the nearest tenth. So area of the base, it is a circle with the radius of 5 centimeters. So pi times radius squared, pi 3.14 times radius squared 5 squared. We're going to get that answer. Where's my calculator? There it is. 3.14, not 114, 3.14 times what? 5 squared. So you can't do 3.14 times 5 and then square it. You have to do 3.14 times 5 already squared, so times 25. Area of the base is 78.5, and then you would take that times the height, 8.3. Let's try that again. 3.14 times 25 equals, so now we got 78.5 times our height, which is 8.3. Now, I want you to look at this. So I've got 751.55. The answer they have right here, 751.88. So I didn't do it wrong. They didn't do it wrong. What could possibly be the reason for just a minor problem there? They have a pi button. So we have a pi button on our calculator, but not every one will have a pi button on your calculator. So what I will probably do going through whenever I am grading homework, I'll probably end up taking both forms of the answer. So, I mean, if you leave pi as pi, that's actually more accurate. It's closer because you're not rounding off anything. But for continuity's sake, if people don't have a pi button on a calculator, it's kind of hard to expect them to know all the digits of pi and put that in there to get a closer answer. So whenever we grade it, you can either use the pi button, or you can use 3.14. Those are the only two values that I would accept to use for that. But whenever we do grade homework, I will have both, just to accommodate whichever one you feel more comfortable with. So with that being said, let's go ahead and try number 2. Find the volume of a cylinder with a diameter of 16 inches and a height of 20 inches. This is what I was talking about earlier whenever I said that this is the formula for the area of a circle. But if they don't give you the radius, sometimes you might have to make the necessary adjustment. They did not give you a radius. They gave you a diameter of 16 inches. So you know that if a diameter is all the way across and it's 16, then halfway across would be 8. So you do have to make that adjustment for the radius to be 8. So I'm still going to take pi, 3.14, times radius squared, so times 8 squared. So see here on my calculator, I do not have a pi button. So 3.14 times radius squared, so 8 squared, 64. I get 200.96. Now leaving that up there, that's just the area of the base. I now have to do what with it? If it asks for volume, I now have to take it times the height, and it says that the height is 20 inches. So I'm going to take 200.96 times 20. Now it says round it to the nearest tenth. That's already the nearest tenth, and that would be my answer, 4,019.2. Now notice this one quite a bit, how do I say it, quite a bit different than the answer that they gave you here. What could be the explanation of that? We did it just a minute ago, and the only thing that we got different here was 651.6, let's say, instead of 651.9. Now we're talking about 4021.2 and 4019.2. So you're talking about a difference of 2 whole units, whereas here you were talking about 3/10 of a unit. Well, whenever you talk about rounding, and the bigger the number gets, so I'm taking and just taking off a little bit of pi, but now I'm taking it times 64 times 20. What did I do here? Here I only took it times 25 and then times 8.3. So the bigger the numbers that I multiply it by, the bigger the difference you will get for the round off error, let's say. All right, so that's the reason why I'm going to take both answers, because sometimes they could look quite a bit different. If you had 651.9 and I had 651.6, you may say, oh, okay, yeah, that's close enough. But then whenever you talk about, being 2 off, or what if I am going to, let's say it's 70 inches tall. Well, now it's even going to be more. So just make sure that you know that there is going to be a little bit of a rounding error depending on what it is actually that you're using, pi or 3.14. Okay, I want you to go ahead and try practice A and B. Practice A and B, and then we will come back together and do them. Please try them on your own first. Okay, back with me. They talk about the volume of each cylinder. So area of the base times the height. Again, we're using the same formula. Area of the base times the height. That's what volume is. So since we're talking about cylinders, we are talking about the area of the base is pi times radius squared times the height. All right, so the area of the base is pi times radius squared. The radius is 3, so I'm going to say 3.14 times 3 squared, which is 9, times 1.8. So with my calculator, I'm going to say 3.14 times 9. Again, where did 9 come from? That's radius squared. 3.14 times 9 times 1.8, and I get 50, and did it say round to the nearest tenth? Yep, round to the nearest tenth. So 50 point, which one's in the 10th spot? The 8, so we look at the 6, makes the 8 go up to a 9, so 50.9. Now let's talk about labels on here. We've not really talked about that. If you're taking 3.14 times 9, so 3 times 3 times, right, this is 3 inches times 3 inches. So you're taking inch times inch times inch. You are actually talking about cubic inches, inches cubed. So inches with a little 3 on it. You can do cubic inches if you wish to write it like that. If you choose to use the 3, make sure it is on the label. Do not give me something that looks like this, 50.9 cubed inches. That is so not the same thing. That means 50.9 times 50.9 times 50.9 inches. That is not the same. Do not write that. If you use the 3, make sure the 3 goes on the inches only, okay? The volume label is always cubed, just like area is always squared. If I wanted to find the area of something, it would be inches times inches, and that would give me inches squared. And then if I take that times this inch right here, that's how we get inches cubed, because I'm actually taking 3 dimensions and multiplying them together. Volume talks about a 3-dimensional object, how much space is inside of something. Okay, so that's what we've got on that. Now, let's do B. Diameter 12 millimeters, height 5 millimeters. Well, they don't really give you a lot of information, but they give you all that you need to know. So we are talking about 3.14 pi times radius squared. What's the radius? It is not 12. So pi times radius, which is half of the diameter. So the radius is 6 times the height, which is 5. Okay, so 3.14 times, let's move this here where you can see it. 3.14 times 6 squared, so that's times 36, times 5. 565.2, 565 0.2. Label, millimeters cubed. Millimeters cubed. Now, we'll be taking off for that label, so make sure we've got the correct one there. Now, if you use the pi button, you will probably got 565.4 millimeters cubed, but either one would be acceptable. Okay, so hopefully we got that going on there. Let's look, and they're going to take it just a little bit further. Just a little bit. Okay, move this down so we can see the whole thing here. A metal paperweight is in the shape of a cylinder. The paperweight has a height of 1.5 inches and a diameter of 2 inches. How much does a paperweight weigh if 1 square inch weighs 1.8 ounces round to the nearest tenth? Okay, so if I want to find the weight of this, we're going to have to do a few calculations here. So one little correction here before we get much further. How much does the paperweight weigh if 1 square inch weighs 1.8 ounces? Anyone see anything wrong with that? If we're talking about volume, are we talking about square inches? No, we are talking about cubic inches. So if it says 1 cubic inch weighs 1.8 ounces, if we're talking about square inches, well then we're so not dealing with the volume, you'd be dealing with the area of something, all right? So they're talking about if 1 cubic inch weighs 1.8 ounces. So the first thing you have to do is find the volume of the paperweight. So pi times radius squared times the height. So I'm going to do 3.14 times radius squared. Radius squared. So if the diameter, it says, is 2 inches, then that means the radius has to be 1, right? Radius half of the diameter. So 3.14 times 1 squared times the height. And the height is 1.5. So I'm going to do 3.14 times 1 squared is still 1 times 1.5. Pi times radius squared times the height. I get 4.71. 4.71 round to the nearest tenth, so 4.7. And I then have to take it and multiply it by 1.8 times 1.8. 8.478, and that is the difference between rounding it and not rounding it. So again, I will give you that leeway there. 8.478. 8.478. All right, so I want you to pause it and try C, please. Okay, back with me. The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 4 feet and a diameter of 1.5 feet. The container is full. How much do the contents weigh if the average weight of the aluminum cans is 37 ounces per square foot? Find the nearest tenth. Okay, same deal as the last one. We need to find the volume. All right, it has a height of 4 feet, a diameter of 1.5. So if the diameter is 1.5, what in fact is the radius? Diameter is 1.5, so that means the radius has to be half of that. 1.5 divided by 2, 0.75. So we are talking about pi 3.14 times radius squared. Now I'm going to put this in parentheses only because it's a decimal. It's got more than one digit, just to keep things straight there. So pi times radius squared times the height. How tall is it? 4 feet. Height, 4 feet, pi times radius squared. So each layer, 3.14 times 0.75 squared times 4. So on my calculator, 3.14 times 0.75. And if you don't have a square button, which I do, but if you don't have a square button, you could always do 0.75 times 0.75, right? That is the area of one layer. And how many layers do you have? 4. 7.065. 7.065. So that's the volume of it. Are we done? No, because it's 37 ounces. 37 ounces. So I'm now going to take that times 37. 261.405. I would round it to the nearest tenth, so 261.4. 261.4 what? They want to know the weight, so these are not cubic feet, anything like that. They want to know the weight. So that would be 261.4 ounces. Okay. Moving on. Volume of a composite solid. Now, here's just a little bit different. So if something is composite, it means that it's made up of more than one thing. Okay? So objects made up of more than one type of solid. So think about like somebody's mailbox. Usually mailboxes are kind of shaped like this. Please don't judge my artwork. Okay, so really what is that? Which we'll be doing this one in the next example. So you've got like a rectangular prism and then like half of a cylinder kind of smacked on top of it. So those things are composite, made more than one shape. Example 4 is the same thing. Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume of the bead. So if this is a bead and it's got a hole in the middle, you can't count this tube in the middle that allows her to thread it on a string because that's not there anymore. Okay? So if I ask you to find the volume of that bead, you cannot include that. So you would have to find the volume of the bead and then just take out whatever the part is that you don't have. So what's the volume of the bead? Area of the base, same formula, 12 times 12. And then how tall is it? Well, if it's a cube, they're all the same. 12 times 12 times 12. That's where the 1,728 comes from. All right? Now, you have to take out the part where she can thread it through, that hole that's in the middle. So if it has a, where are we at here? 2 millimeter diameter. 2 millimeter diameter. Then that means it's a 1 millimeter radius. So 3.14 times 1 squared times 12. Now, how did I know that was 12? Because this is a cube. So if it's a 12 by 12, this right here also has to be 12, which is the same height as that cylinder right there. So 12 by 12 by 12, which means the height of this is 12. So 3.14, which they leave as pi, times 1 squared times 12, which is 37.7. Now, why are they subtracting this? Why are they subtracting it? Well, that's air. That's an empty space in there that you don't have. So that's where they put the thread through there. So it's 1728, 1,728 minus 37.7, which leaves you a final volume of 1,690.3 cubic millimeters. So sometimes you may have to add them, sometimes you may have to subtract them. Just depends on whatever the shape is. All right? So let's move on to the next page, and you'll see a much better looking mailbox than the one I just did. Okay. Well, they call it a storage chest. I call it a mailbox. Whatever you want to call it. D, let's do this one together. Okay. So we have to find the volume of 2 different shapes here. So we need to first find the volume of the first one. Well, wouldn't that make sense? First, find the volume of the first one? Yeah, that makes great sense. So let's do the prism. Right? Prism. Area of the base times the height. Area of the base times the height. So whichever one you want to use the base doesn't really matter to me. If you want to do 25 times 50, take it times 30. Or if you want to do 30 times 25 and then take it times 50, almost like it was setting on this end right here. Set it up on its end. Either way is going to work. What property says we could do that? Commutative property says that we could change around how we multiply. So getting my trusted calculator back out here. I've already got it done right here for you. 30 times 25 times 50. Whoops, 37,500 cubic centimeters or centimeters cubed, however you want to write it. Now, if you would have done it the other way, you're going to get the same answer. If you would have done 25 times 50 times 30, 37,500. So either way you want to do it is fine. So this is, come on, volume of the prism. So that's the volume of the prism. You now have to find the volume of the half of a cylinder, which is resting on top of it. So half of a cylinder that is resting on top of it. That's what you've got to find next. Okay? So how do you find that? Well, it's volume of the base, area of the base times the height. The area of the base, it is a circle, right? Even though you only have half of it, we'll deal with the half later. Let's pretend like we have the whole thing here. We'll pretend like we have the whole cylinder, and then we'll take half of it later. So we've got, let me get a pen that's a little darker here so that way you can see that. So volume is going to be area of the base, so 3.14 times radius squared times the height. So 3.14 times the radius. Now, it doesn't tell you the radius or the diameter expressly. So you have to figure that out. You don't have to be mathematicians, you just have to look. Those are the same, are they not? So if it's 25 centimeters across, then that means the diameter is 25, which would leave the radius to be 12.5. How tall is it? This is how I said earlier, where this could be the base, and you could set it on its end. Well, you're going to have to do that this way. So the height of it, if this is the base, right? So envision like a cylinder standing up this way, right? If you had half of it. So this is actually the base, which means this right here would be the height, because that would be how tall that is right there. Well, how long is that? 50. So using my trusty calculator, I've got 3.14 times 12.5 times 12.5 times, how tall is it again? 50. Now, that would be if we had the whole cylinder, but there's not a whole cylinder sitting on top of there. It's only half of it. So I'm going to divide this answer by 2. Leaves me with 12,265, and I'm going to round that to the nearest tenth, 0.6. Let's add those two things together. 12,265.6 plus my 37,500 from my prism to begin with. I get 49,765.6, and that is my final answer. 49,765.6 centimeters, what? Centimeters cubed, because it's volume. Okay. Now, if we would have left pi as pi on that, you would have got a slightly different answer, 49,771.8. So again, just like I told you earlier, the bigger the numbers you use, the bigger that gap is going to be. Okay. So with that being said, hopefully we've got this. Remember the formula for the area of a circle and the formula for volume. Okay. So volume, area of the base times the height, and it just so happens that the base of a cylinder is a circle, so you need to know pi times radius squared. All right, so have fun with those. If you have questions, come see me. Good luck.